Alright, so we're beginning chemistry. This entire semester is now chemistry. Last year they thought it was easier than physics. There'll be less math, more vocabulary. So the first thing we're going to be looking at is what's the difference between physical and chemical. We'll be looking at the properties and changes. So what is a property? That's a state, a matter. So words have different meanings. A property is a description of an object. Yes, solid, liquid, gas can be a description of it. The tree is green. The tree is tall. If the tree is struck by lightning, the tree can catch on fire, so it can burn. It's flammable.
The tree getting struck by lightning is crazy.
Alright, cool it, guys. So, physical properties, guys, cool it. Physical properties are determined by using the 5 senses. What you can see, taste, smell, hear, touch. They are a description of the object. Examples of physical properties: its color, its smell, its taste, its hardness. Does anyone know what hardness is? That is exactly the type of hardness I'm referring to, the scientific term of hardness. On the mole, something like that scale. More? I think it's more. Now I have to look it up. Yeah, it's MOHS, Mohs scale. I'm probably pronouncing it wrong. Basically, it's a relative scale. For example, diamond's the hardest. It's whether or not two things can scratch something else. So when we say hardness, we're referring to whether or not one object would be able to scratch another object. They're actually very brittle.
What is?
Diamonds. They're very hard, but very brittle. That means you can't bend it without breaking. Because it's very hard. That means it's not very brittle. That means it's ductile. State of matter is an example of a property. And by the way, these are all the physical properties. Boiling, freezing, and melting point is an example of a physical property. Density. Density is a physical property. Does anyone know the equation for density? Mass over volume. How much mass you fit in a single space? One way of looking at it is if something is less dense than water, it'll float. If something is more dense than water, it'll sink. What was your question? Because you're taking up the space of the water, pushing it away. I mean, it's the same thing as getting a sheet of wood, putting it in, and then pushing it, filling up the water on the left side. Like you're literally pushing the water over. Technically, density is not the reason why things float. It's buoyancy. But if you're talking about a solid object, like a block, then density can be used. It's the reason why you can have aluminum boat. Aluminum is more dense than water, so normally aluminum would sink. But the reason why aluminum boat floats is because it's open and you have air in it. If you include the air and the aluminum, then overall it's less dense than water. Mass is a physical property. Volume is a physical property. Malleability. Malleability is the ability to be molded, bent, or I like defining malleability as like if you have like gold is extremely malleable. You can get a hammer and hammer a block of gold down to 1 atom thick. Keep your mask on. No.
No, the shoe. The face shield. The face, like the clear, the glass on there. I was going to ask you about this. No, it has gold dust in it.
Oh yeah, it still reflects radiation and sunlight. Yes. It is. Yeah. I mean, the only reason you see something is because it's reflecting into your eye. That means the sunlight is hitting your eye. Now, if you look directly up at the sun, it looks bright, right? But if you look off away from the sun, it's not reflecting off of anything to go into your eye. If you took a mirror, pointed it at the sun, and looked in the mirror, it'll hit the mirror and bounce into your eye, blinding you. Alright, guys, cool it. So malleability can be also thought of as the ability to flatten something, to hit it, and mold it into a shape. Solubility is the ability to be dissolved. So if you put sugar or salt into water, it'll dissolve. Solubility actually depends on temperature. You can dissolve some salt in water, some sugar in water. But as you raise temperature, you'll be able to dissolve more and more. Chemical properties are determined by the substance's ability to react with other substances. So a physical property can be determined by only using the 5 senses, and it describes the object. A chemical property cannot be known by merely looking at it. It is determined only or solely by the ability of that substance to react with other substances. For example, if I put a yellow liquid, let's say yellow Kool-Aid, in a glass, and I put gasoline in a glass, and Cody, keep your mask on, without smelling it, just by looking at it, and let's say they're exactly the same color, would you be able to know which one was flammable without trying to react it and catch it on fire? Again, without smelling it or reacting it. Again, that's reacting with your taste buds. But just by observing it, the only possible way is to do some chemistry on it. Either have it react with your taste buds, react with your nose. So, the ability to react with air is one example. What's some ways that things react with air?
I see like where people will like they'll be in like a gas plant sometimes, and then like gas will be in it, and then somebody will like cigarette.
So that's combustion. Combustion is reacting with oxygen. Rust. Does anyone know what rust is? It's not water in there. It's oxygen reacting, but water has H2O. So the O molecule can break off the water molecule to react. Tarnish. Does anyone know what tarnish is? Does anyone have any silverware?
Yeah.
Is it tarnished? Let me show you a picture. So tarnish is very similar to rust. It's lose or cause a loss of luster as a result of exposure to air and moisture. It's a thin layer of corrosion, kind of like rust on copper, brass, and aluminum. So mostly when we think of tarnish, we mostly think of silverware. It's where sulfur comes in and attacks the silver, turning it brown. So when oxygen mixes with something, it becomes rust. So when oxygen mixes with a metal, such as iron, it turns into iron 2 oxide and becomes rust. When sulfur mixes with silver, it turns into silver sulfide, which is a tarnish. And this is chemically reacting. So instead of oxygen reacting, it's sulfur when you're referring to silver tarnish. But mostly tarnish is a looser definition of rust. A tarnish refers to it losing its shine, so it gets a dull appearance. Corrosion, which I believe that was the next one. That's just generic corrosion. Rot. The ability to react with water and acids. So sodium, for example, if you take sodium and put it in water, it will immediately catch fire. And keep your mask on. The ability to catch fire is called flammability. Note, these things can only be observed if you actually expose it. So if you to see if something is rust proof, if you were to buy something with a sign, this is stainless steel, rust proof. You won't really know if that's true or if they sold you a fake unless you see it rust. So, question. The ability of a gunpowder and fire to explode, is that physical or chemical property? Chemical. You won't know until you try lighting the powder and fire to see it explode. The color of a sunset. Physical. You can just look at it to see this color. The ability of a nail to rust. Chemical. The shape of a leaf. Physical. The ability of wood to burn. Chemical. The hardness of a diamond. Technically, this is physical. Again, you can pick up the diamond and squeeze it and feel it and tell that it's very hard. Even though technically how hardness is defined, you have to scratch it to something else. But when you scratch something with another object, you're not doing any chemistry with it. A chemical change undergoes a chemical reaction. So if I take a diamond and scratch it on some glass, I'm not chemically changing the glass or the diamond. It's still a diamond. It's still glass. The glass might have a different shape. It might have scratches in it. but I didn't change the chemical makeup of the glass. The volume of your Coke, physical. The mass of 2 camels, physical. So physical changes versus chemical changes. A physical change is a change that occurs without changing the identity of the substance. No new substances are formed. So examples of physical changes: a change in size, shape, or color, pencil shavings, torn paper, crushed ice. Note, sugar dissolving in water. Keep your mask on. So when you dissolve sugar or salt in the water, you aren't changing the chemical. Whenever you dissolve something in something else, it's not changing the chemical. If I put salt, so salt is salty, right? Put some salt on your tongue, it tastes salty. If I put some salt into water, the water tastes salty. You didn't change salt in the sugar or do anything magical to it. It's dissolved in it. All you're doing is dispersing the salt throughout the liquid. Painting the wall, all you're doing is changing color. You're not actually changing the paint or the wall. Chemical changes is a change that causes the identity of the substance to be changed. Something new is formed. And Michael and Thomas, y'all lift y'all's head up. So when a chemical change occurs, something new is being created. New substances with new properties are formed. So if you mix 2 clear liquids together, and all of a sudden in this picture on the left you see this reddish powder or reddish substance being formed. If you see a new color appear, that's also, by the way, the top left one is a precipitate. It's called precipitation whenever something falls out of solution. But if a color or a new color to appear, that's usually evidence that a chemical change has occurred. Whenever you start heating up a piece of paper and you start not catching on fire, but you start heating up, it changes colors, starts darkening. Whenever you cook your food and it starts turning brown or black, that indicates that a chemical change is happening. What you're doing is breaking down the proteins and the carbohydrates in the food, and because the chemicals are breaking apart, you're creating something new. It's the reason why cooked food tastes better than uncooked food. Thomas, keep your eyes open and lift your head up. Michael, mask on. Bubbles are fizzing. Have any of y'all done the volcano experiment in elementary? Where you do volcano and vinegar, vinegar and baking soda? So if you put something in your drink and you start seeing bubbles, no, I would say, if you put 2 things together and they start fizzing, that's usually the indication that a chemical change is occurring. Not always. For example, putting Mentos in a bottle of Coke is a physical change. You're forcing all the dissolved CO2 out very rapidly, but all you're doing is making something dissolve, not dissolved. Usually, though, it's evidence of a chemical change. What? Elephant toothpaste is most definitely a chemical change. Precipitate forms. A precipitate is just a solid material that comes out of solution. If you mix 2 liquids together and something solid forms, that's a precipitate. Heat is generated. So if you mix 2 things together and it gets super hot, that's usually evidence that a chemical change has occurred. Not always, but usually. Light is produced. So think of fire. Fire is a chemical change. Fire is combustion. It's mixing whatever material with oxygen. Oxygen is physically attaching itself to that chemical, creating a new chemical, sometimes ripping a carbon off and forming CO2. Sound giving off, if you hear something hissing. Another important thing is usually one of the most important evidence of chemical change is they're difficult or almost impossible to reverse. Have you ever burned a piece of paper and then collected all the smoke and ash and reassembled it into a piece of paper? You ever struck a match and decided, I'll just fix it and reuse it later? Whenever some metal starts rusting and starts forming holes in it, can you reverse the rust? You can remove the rust and throw the rust away, but you can't undo the rust. If you see rust, it's already damaged. You can't undo it easily. Vinegar plus baking soda produces a release of carbon dioxide gas. Oxidization, iron plus oxygen is rust. Do you know what the difference between combustion and rusting is? They're both oxidization. The only difference is how quickly it occurs. Oxidation that is very slow and over long periods of time, we call rust. Oxidation that is so fast that generates so much heat it starts glowing and producing a visible flame, we call that combustion. But both of them are an example of reacting with oxygen. Reactions with electricity, such as silver plating. If you run electricity through salt water, you can break it apart. And Thomas, keep your eyes up and your head off the table. Reacting between substances. If you take sodium and chloride and combine them together chemically, you make sodium chloride, which is table salt. Silver and sulfur from the air can cause tarnish. Is what gives you this color on silverware, this real silverware. So if you have any old, fancy silverware at your house and you see this on it, it actually is a good indication that, yes, that is real silver. Because aluminum and steel rust, they don't tarnish that well. Wood burning, metal rusting, food digesting, gasoline burning, cake baking, all these are examples of chemical changes. So let's do some examples. Water evaporating from the ocean, physical change or chemical change? It's physical. It's still water, it just changed state. It's water in the gas state versus water in the liquid state. The yolk of an egg, which contains sulfur, causes tarnish to form silver. Chemical. It's the sulfur actually attacking the silver. This is the reason why it should be avoided or at least washed thoroughly if you're going to use any silverware with eggs or baked goods. Physical or chemical change. The ice on a lake melts to become water in the lake. Physical. Again, another thing that can be done is how easy can it be reversed? You can put the water back in a freezer and freeze it. Very easy to reverse, so that tells you physical. Charcoal in a fire turns to ash after several hours. Chemical is very hard to convert ash back into charcoal. A pencil is sharpened in the pencil sharpener, leaving behind shavings. It's physical. It's kind of difficult to reassemble it back into a pencil, but not impossible. You can take the wood shavings and recycle it and turn it back into a pencil. Pencil takes or turn it into paper. It's still wood. A battery emits electricity to turn on a flashlight. Electricity is usually chemical.
What you say, Richard?
It's actually what's causing is a chemical reaction inside the battery. It just so happens that we make batteries, rechargeable batteries, where if you run electricity back through it, you can actually reverse the chemical process to some degree. So again, the evidence or the fact that it's difficult or almost impossible doesn't hold always, but electricity generation is through a chemical mean in a battery. Bicycle rust when left in the rain.
Another example of something that you can use chemically.
That would be a battery. Battery is the only example I can really think of. Another example is hydrolysis of water. So you run electricity through water and it breaks into hydrogen and oxygen. If you burn the hydrogen, it will react with water and form ion react with oxygen in the air, recombining the H2 and the O2 into H2O. So a bicycle rusting when left in the rain is chemical. A shirt is accidentally torn in the washing machine. Physical, you're not changing the chemical makeup of the shirt. You're only physically altering it. A log is split into two by an axe. Physical, it's still, you just now have two smaller logs.
Then my turn. Anyway, yeah.
All right, let's discuss some of the more difficult ones that the PowerPoint didn't cover. Sour taste. Physical? Is it physical? So can you look over something? Yeah, that definitely looks like it tastes sour. Okay. Again, so if it's chemical or if it's physical, it doesn't react with anything. You can observe it without changing the chemical makeup. If it's chemical, you have to change it. So can I put can I take a warhead, stuck on it, and say yes, this is sour, and put it out and put it into hand it to you? Would you take it, or do you think somehow I've chemically changed it once it goes in my mouth? Sour taste is actually chemical. Your taste buds are chemically reacting with that substance.
And it does become sweet after a while.
That's because the outer layer is sour. So sour taste. Whenever it says the five senses, I would not do like actual taste by itself. I would do it's kind of hard to do taste. Almost all taste is going to be chemical if you actually taste something. Let's see. Luster. Does anyone know what luster is? What's the definition of luster? The ability to shine. If something is polished, it has a high luster. If something, the opposite of luster is dull. Odor. Oh, this is 50-50. I see some PowerPoints say odor is physical, some say it's chemical. I'm gonna go with chemical for this class. Keep your mask on. It's actually physical or chemical. Sour taste is, again, you can argue sour taste is also physical or chemical. It depends on where your stopping point is. Because odor, in order to smell something, it has to react with your olfactory nerves. Olfactory is is another word for smell. It has to actually bind and do chemical reactions with your nerves in order for you to actually smell it. Same thing with taste. So, I'd say on 7 and 13, put a P/C on it. It could be both. I think on this paper they wanted you to put on 13 and 7 that's physical. Because according to this, physical properties are observed with the senses. But another thing about chemical is there's a chemical reaction going on. Whenever you taste something or smell something, at the innermost level, you are changing it. 7 and 13, I think they wanted you to put physical on it. But again, I see some places they put it as chemical. Because, for example, cyanide. If you were to take a big whiff of cyanide, do you think some chemistry might be going on? I definitely don't want to smell cyanide. So on the back, they do the first example. A student removes a loaf of bread, hot from the oven. The student cuts the slice off the loaf and spreads butter on it. Is this a physical or chemical change? It's physical. What evidence? The bread doesn't change. It stays bread after it's sliced. There was no color changes. You cut it. You didn't change the color inside it. There was no temperature change. So the evidence is provide the evidence for why you think it's physical. For the most part, you're just copying these descriptions of it. So, physical change is one where no new substance is formed. Any questions? You don't finish? How much time do we have in class? 10 minutes? Yeah, I don't think I'll finish. Turn it in tomorrow. I think I'm going to start deducting like 10 points a day. 10% a day. After tomorrow. So let's do tomorrow if you don't finish in class. But just for 7 and 13, put P/C. The reason why 7 could be chemical is the word